All right, pre-algebra, good news is we are doing one section for today's lesson. We are just doing 5.3, which is exponents and multiplication. It's going to blow your mind a little bit, but that's okay. We'll all recover. I will warn you, the Chiefs game is still going on, so you may hear more random cheering from Mr. Mo. Our learning goal for today, and I think we'll kind of skip over this warm-up and talk about it maybe in class, is to apply the properties of integer exponents to create equivalent expressions. So we're taking kind of a different look at what we're doing versus yesterday's lesson. So let's check it out. One important thing to remember is that exponents are really just a shorthand way to write repeated multiplication. It's going to make it more efficient and more precise. So I can say something like 7 squared times 7 cubed instead of saying 7 times 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 7. It's easy to lose track of how many sevens we've just multiplied, but if we write it this way, it's a lot easier for us to stay organized. So when we're doing this, what's going to happen is sometimes unexpected, but when we stop and think about it, it actually makes a lot of sense. So for example, when I say 7 squared, that means I'm doing 7 times 7, right? And then I'm going to multiply that by 7 cubed, which means I'm going to do 7 times 7 times 7. Oops, that's 3 sevens, which is what I wanted. So I have 7 cubed, 7 squared times 7 cubed. So what I actually have is 7 multiplied by itself 5 times, right? So 7 is a factor here 5 times. So what that means is my shorthand little explanation for this, or my shortcut, is that when I am multiplying powers with the same base, right, both of these are sevens, I am actually going to add the exponents. So I can think of this problem, 7 squared times 7 cubed, as 7 to the 2 plus 3 power. So it's really the same as 7 to the 5th power. And we can see that by multiplying it out because my exponent tells me how many times my base is a factor. So when I actually multiply 7 squared times 7 cubed, I see that there are 5 sevens being multiplied, or 5 factors of 7. So this answer should make sense to us. So when we see this, let's remember that when I am multiplying the same base, I'm going to add the exponents. And it's going to help us all out if I write the correct information here. So 7 squared times 7 cubed equals 7 to the 2 plus 3 power, which is 7 to the 5th power. So that's what it looks like in arithmetic or with numbers. But in algebra or with variables and our letters, we would say that a to the m times a to the n equals a to the m plus n, because I have the same base, so I'm going to add my exponents. And I'm going to tell you right now, you are going to forget this rule sometimes. So it sounds simple, but I really want you to focus on what it is we're doing here, because it gets easy to get confused down the road as we keep adding new rules. So let's look at a couple here to help you practice. We can use these numbers from the box over here to fill in the blanks over here. So in letter A, I'm doing 5 squared times 5 to the 8th power. I have the same base, they're both 5s, so I keep the base and I'm going to add my exponents. So this is the same as 5 to the 2 plus 8 power, which 2 plus 8 is 10. So we could say 5 to the 10th power. On part B, this time I'm multiplying x cubed times x to the 5th times x to the 10th. Well, I'm multiplying and I have the same base, so I can keep that base, and now I'm going to add my exponents. So this is the same as x to the 3 plus 5 plus 10. 3 plus 5 is 8, plus 10 is 18, so this is the same as x to the 18th power. Now sometimes, like in letter C, we're going to multiply and have some coefficients in front of our variables. So I still need to multiply everything here. So I'm going to multiply my coefficients, 2 times 5, and then I'm going to multiply my exponents. I have m to the 10th times m squared. So since I have the same base, I keep that base, and I'm going to add my exponents. So this is going to be m to the 10 plus 2 power. So as I simplify, 2 times 5 equals 10, and m to the 10 plus 2 power equals m to the 12th. So far, so good? All right, well, let's let you take a turn here. If you would like to pause the video and try to work this one out and then check your answer, that would be a good test for you. So I am multiplying 3y to the 4th times 5y to the 7th. So I can multiply my coefficients, the numbers in front of my variables, and I can multiply y to the 4th times y to the 7th. So my base is the same, so that stays the same, and I'm going to add my exponents. And now as I simplify, 3 times 5 is 15. 4 plus 7 is 11, so I get 15y to the 11th power. Hopefully you did too. All right, so let's look at x to the 8th times x squared. And let's determine if this has the same value as x to the 5th times x to the 5th. So let's use our rule here to figure this out. My factors have the same base. They both have a base of x. So I can keep my base, and now I'm going to add the powers. We want to know if this has the same value as x to the 5th times x to the 5th. Again, my factors have the same base, which is x, so I can add the powers, which is 5 plus 5. And now as I simplify, 8 plus 2 is 10, and 5 plus 5 is 10. So I do see that indeed, yes, they do have the same value, and I can justify that answer by showing my work here. That when I have factors with the same base, the base stays the same, and I add the exponents. So even though the exponents are different, they still add to the same total power. If I wanted to also, I could show x to the 8th as x as a factor 8 times, and then I could multiply that by x squared, which is x as a factor 2 times. And then I could do the same thing over here with x to the 5th. There's x to the 5th times another x to the 5th. And I could count all those out and see that I really have x to the 10th equals x to the 10th. So here is a slightly different scenario, and this is the one that's easy to get mixed up with what we just talked about when we're multiplying. Sometimes we're going to do what's called taking a power of a power. So some expressions containing exponents include a different relationship, so we need a different property to solve. For example, this one, we have 5 squared, and this whole expression here inside the parentheses is being raised to the 3rd power. So I have 5 squared to the 3rd power. So what this means is that 5 squared is a factor 3 times. So I'm really saying 5 squared times 5 squared times 5 squared. So if I break this out, or break it down a little bit, 5 squared means 5 times 5. 5 squared again. Oops, I missed a parentheses. Each of those 5 squared represents 5 times 5. So now if I look and see how many times 5 is a factor, I can see that in my first set of parentheses, I have 5 to the second power, and I can add all of these up now. Then I have 5 to the second power again, and I have 5 to the second power again. So I really have 5 to the sixth power. Or if I wanted to just count, I have 1, 2, 3, 4, 5, 6 times I'm multiplying 5 together. So 5 to the sixth power. So if that is the case, then clearly I have a little bit different rule because I'm not adding my powers when I do power of a power. When I find the power of a power, I need to multiply the exponents. So we really need to keep track of when we are doing power of a power and when we are just multiplying exponents that have the same base. So for this example here, when we're looking at a power of a power with arithmetic, I'm really doing 5 to the 2 times 3 power, which is 5 to the 6th. If I'm doing it in algebra with variables, a to the m, all raised to the n power, would be a to the m times n. Let's practice a couple. On letter A, I have 10 cubed, all raised to the second power. So my base stays the same, it's a 10, but I'm doing power of a power, so I'm going to do 3 times 2, which is 6. And let's cross that out because we've used it. On letter B, I have x cubed to the 4th power. This is power of a power, so I'm going to keep my base the same and multiply my exponents. 3 times 4. Good news, Chiefs won. Woo! Oh my gosh. Okay, so power of a power, so 3 times 4 is 12, so this is to the 12th. And in letter C, we are doing a to the 5th raised to the 6th. So this is power of a power, so my base stays the same, and 5 times 6 is 30. If we want to break these down a little further, just so that we can see how it works, I could rewrite letter A as 10 to the 3rd times 2. And on letter B, I could say x to the 3rd times 4. And a to the 5th times 6. All right, let's let you guys try one more here. Okay, let's jump ahead to this last section so we can talk about power of a product. To find the power of a product, we're going to raise each factor to the power. So when I say 2 times 3 cubed, that means I'm going to do 2 times 3 times 2 times 3 times 2 times 3, which is really, I'm multiplying 2 by itself 3 times and 3 by itself 3 times. So I'm really applying that power to each factor. One thing that is important to remember on this is this rule is called power of a product. So this only works when we are multiplying inside the parentheses. So 2 times 3 cubed means 2 cubed times 3 cubed. And in